might have seen these recommendations in various other e-commerce websites, Netflix, Amazon, Flipkart. So basically these recommendations are provided to cross-sell products and upsell them, basically horizontally and vertically. So within the same vertical, let's say if you are viewing a particular moisturizer, what other things could you suggest within that same vertical? Whereas cross-sell could be, let's say if you're looking at a jeans pant, maybe a t-shirt could go along with it or stuff like that. So hope you recognize these screenshots because my talk will be building upon this. Yeah, so now I'll like to briefly explain upon how collaborative filtering and recommendations in general work. Just a short introduction. So let's say you have this person here who's, let's say, interested or bought these 2 items, whereas this person has bought those 3 items. So when this kind of pattern occurs sufficiently in your data, you could probably correlate that maybe this Coke is somehow related to these 2 items. In a way, that's how most collaborative filtering algorithms work. Okay. Oh, okay, sure. So yeah, so when I said so this Coke is now kind of correlated, saying that it could probably be related to these 2 items. So the beauty of this approach is you don't need to know what a pizza is, you don't need to know what a salad is. All you need to look in your data is how many times this kind of correlation is occurring, right? So that kind of tells you that people are sort of interested in this. You don't know what that is, all you know is it is important. So right, so this has a lot of advantages, as you realize. You don't need to know any semantics of the items, but the disadvantages are also there. I'll probably, if there's enough time, I'll come to that. So yeah, this is well and good, but the problem that happens is when you plot, let's say if you take all our Flipkart products, 15-20 million products, and plot it in a graph saying what are the activities happening on each product. Activities, let's say selling, how many products are selling and how many products are whatever, the number of times the product is sold, right? If you plot it in a graph, you would kind of get something close to like this. This is, most of you might know, this is a long tail kind of graph. It's a power law. What this basically says is in your catalog, 20% of your products are very popular, approximately, whereas the other 80% are not that popular. So what I mean by popular is, again, internal thresholds and stuff like that. So when you're saying 20% are popular, you are able to provide good recommendations for them because you have enough data around those products. So when you have good data around those products, let's say a lot of people are buying a mobile phone with a case cover. So that could give you a good correlation between those 2 items. Whereas something along here, if not many people are buying it, you have no way to say what this particular thing is related to, right? So when you have close to 80% of your catalog falling in this long tail and hence not good recommendations coming in, that is a problem that you'd like to address, right? So this is what we call a sparsity problem, because not enough data is there around those products to solve, to give recommendations, basically, right? So the next thing that I'm going to talk about is how we have tried to solve the sparsity problem, right? Whereas this long tail, I'm not going to touch even, not at the start, because here anyway we're getting good recommendations. This particular thing is what needs to be addressed so yeah. So okay, so this is a brief solution from a very high level. So let's say you have in your catalog, it could not necessarily be an e-commerce catalog, it could be a Netflix movie catalog, whatever, right? So you have some root movies, and then you could probably have something drama and stuff. So here, let's say there's a category tree that we have in Flipkart. So you would probably have a root node, and then so on and so forth, and here you will have shoes. And then it further gets categorized into running shoes and casual shoes and so on and so forth. These would be the leaf nodes, right? So what I'm saying, what this approach is trying to say is, a lot of good activities happening around this canvas shoe. So whereas not much around this non-popular shoe, not many people are interested in it, right? So what I'll be doing, this technique tries to leverage the good activity around this and try to recommend stuff for this. That's a solution at a very high level. So how this happens, we'll get to know as I come to the demo section. So this is briefly the approach that we have developed. First is form a cluster of products, and after forming the cluster of products, we do co-occurrence analysis on this, and finally try to leverage the affinities that we formed. Normally this approach is done at a PID level, at an individual product level, but doing at an individual product level, again, because of that long tail phenomena, what you end up having is not good recommendations or not enough data to give recommendations, right? So yeah, these are some of the examples that before I tell how we've developed this product cluster, I just like to give a few examples of what this cluster is. Right? So this is one cluster about mobile phones, one about garments and baby products. What this cluster is made up of is, it's made up of all Motorola Android phones within this price range. Whereas this is a garment with these attributes, and same with baby products, right? So a baby product might have an attribute of 0 to 3 months, brand and price range. So what's the big deal about this, right? So a particular product in this particular category might have 30-40 attributes. So a pant might have number of pockets, type of zipper, is it a metallic zipper or plastic zipper, a lot of other attributes, right? How do you know which attribute is important and which is not? How do you know brand is important and a number of pockets is not important? So why do you need this? So if you, let's say, form a cluster with very loose attribute, let's say number of pockets, the number of products that map to that cluster will be very less. And moreover, when you are actually trying to show this to a user, how many of users would like to buy, would differentiate between products which are 2 pockets and 3 pockets? It's not many people will be interested in that kind of products and cluster. So trying to find an important set of clusters, important set of attributes to form the cluster is very important. So the way that we have approached this is, of course, there are other data mining approaches, not data mining, sorry, machine learning approaches wherein you will find how to attribute a weight to a particular attribute. Like for books, if you say there are thousands of attributes, right? So maybe you have what do you call, publisher, book type, paperback, so on and so forth. But author is one of the most important attributes there. So yeah, so how do we know what attributes to choose? So the way that we've approached this is, we tried to, we looked at the click logs that we get at Flipkart and try to see what people are clicking and what they end up going to after that. So for example, this is one entry of a log line. I've kind of truncated it because it was too big to fit in this slide. So this particular person from this IP was looking at some Apple product and he was viewing it basically. He was viewing it and this is the product ID of it. So he came to this particular page after selecting certain filters and searching on the Flipkart website. So we try to track this entire route and what filters he ended up choosing which led to this final result is what we kind of note down. So this kind of, when you analyze the logs over a period of time, this roughly tells you what attributes customers are thinking are important to them. So as an example, let me give you this, right? So this particular thing, if you see on Flipkart website, right? So you will see on the left side various ways to filter your search results or filter your browsing, right? So in tablets, you will see brand as a top section here, price as a second, screen size as third. So this is not randomly placed. This is arranged based on what users are thinking that particular section is important or not to them. So for tablets, people seem to be more interested in brands as opposed to, let's say, accessories. Whereas for trousers, it is like size first and then brand later on. Whereas for t-shirts, brand is first and color seems to be more predominantly important. So this kind of tells you what is, so we have crowdsourced this whole thing of determining what is a good attribute or not. So I think this gives you a better approach rather instead of using machine learning techniques, because this kind of can take care of any trends that can happen later on. Let's say after a while, due to some reason, this tablet accessories are leading to more importance in customer behavior. This will naturally bubble up. So that's what you would want, because machine learning might not catch those small subtleties. Okay, cool. So I'll have to talk a little bit of math, because till here what we have is just clusters floating around. We don't have any linkages or no affinity between clusters as of now. They're just like clusters just floating around and no connection as of now. So the way we do it is, okay, so each cluster is plotted as a vector in a n-dimensional space. So here you are seeing a two-dimensional space. So let's say this D3 is one vector, D2 is one vector, and so on. And let's say there's only two clusters right now. So now how do we find out what's the distance between this and this, right? So the way that we approach this, we used a cosine similarity. So what that tells you is the dot product of these two vectors. It's a angle between these two vectors. So of course in our data we did not have just two vectors, we had n vectors. So why is this important? So there are other, so if you remember your geometry lessons, there is Manhattan distance, wherein you have this distance between 2 points in a two-dimensional plane and stuff like that, right? So Manhattan distance is one more thing that we tried, but what was happening with those other measures was, if let's say certain cluster like mobile phones, which are very popular at Flipkart, so they are bought almost with all other products. So what happens is, mobile phones will come almost with every other cluster. You don't want this kind of behavior, because you'd want the customer, so if I show jeans pant with mobile phone, there's no value in it. I can of course say data is showing it, but then you'd want to show him something good, right? So cosine similarity gives you a normalization, because in the denominator you have a normalization factor here. So this takes care of, this becomes length invariant. So the length of a vector kind of is not a factor. So this gives you a score. Sorry. Yeah. So this gives you a score between let's say this D3 vector and D2 vector. So that score kind of is a indicator of how close they are, right? So now, so I need to mention some numbers, because unless this is mentioned, it is not, you can't know that this approach is scalable or not. Because you can do this on a small set of data, but then at Flipkart scale, if you have to do it, it has to be scalable, right? So this approach currently generates about 1 billion item sets. That is after our thresholding that we put in. Thresholding, by thresholding I mean we have various checks to see if it is not a bulk order or not. So if someone orders like 50 bags and 50 pants, that should not screw my data up. So we have certain thresholding defined in our data, so which neglects all such errors. So this is after those thresholding 1 billion item sets. So finally we end up generating about 60,000 clusters. So for our catalog of about 20 million products, this approach covers about 99.4% of our catalog. Okay. So this kind of, if you see this percentage, this, and if you remember the earlier slide about long tail, this tells you that this has a very good coverage. But of course I like to make a point here, coverage need not necessarily mean good quality, right? So for example, at least recommendations is far more forgiving that way, because search results, when you type in something, if you type in Adidas, you'd want to see something regarding Adidas. You can't be too experimental there. Whereas in recommendations, at least have a little bit of leeway. But that need not necessarily mean I can show him any random thing, right? But still, again, this coverage does not necessarily mean quality. So what data did we consider to generate these clusters? So we generated clusters using all the sales and browse data. So this accounted to about 300 million entries, I mean, as an input to our algorithm. So that's it about various numbers. So coming to examples. So internally, after, let's say this is one cluster of baby walkers. those small workers, right? So after I compute the cosine similarity, I'll get let's say this kind of a graph that we represent internally. Baby bouncers seem to be more predominantly linked with this, whereas potty seats seems to be next, strollers is next, and so on and so forth. So if you see, these kind of clusters are kind of complementary in a way to the main cluster here. Complementary, I mean, when someone is buying a baby walker, you are not only suggesting other types of baby walkers, but you are also suggesting complementary items. Like baby walkers might mean he has a baby, and maybe baby soaps could also be helpful to him, or baby wipes, so on and so forth, right? So all of these are related to baby usage, right? So, but inside Flipkart, we represent this in a console in this way. Same thing actually, what you saw, baby bouncers here, and so on and so forth. So first is baby bouncer, and so this tells you a lot more information, because this cluster is made up of these attributes. Mother Touch is a brand and price range. So again, this not only tells you about the cluster, so the significance of this is, this tells you all the products with these attributes have an affinity towards all the products with these attributes, whereas all the products of these attributes. So it's not just one product that we are talking about. Right. So I'll just give you this example because this is very important to wrap up the talk. So I think I'm out of time, but yeah. So this was a product that was recently released in Flipkart website. So as a result of this, we did not have any recommendations. It was newly released. So you will just see, within a day or two, you will just see this, which is just a very loose recommendation. Right? So when you put the same product ID in the console, the heels, shoes, pavers, England, you would see some good stuff. Handbags, women tops, wallets, wristwatches. So how did we get to this? Because when you see at the bottom, so this particular product fell in a cluster where other products had already been bought and had activity around it. So for example, if you see this guy here, there's some 3 ratings and I'm pretty sure it's been bought. Whereas this guy here, so people have done some buying other stuff with this sandal and stuff. Sandal, right? So that helped us leverage the recommendations that are getting formed here to show it for this guy. Right? So this is kind of a mock-up. It's still not there on website, but ultimately we are hoping that product groups, internally we actually call it product groups, but yeah, for the presentation it was retermed as product clusters. Don't get confused with this here. So this is the final thing that hopefully it will emerge on the website, wherein if let's say you are seeing this, you will see what are the other complementary groups that you could see, you know, kurtas, watches, handbags, that kind of acts as an accessory to this. What are the other synonyms? I have not yet talked about synonyms actually. So complementary is one thing, but synonym also is important because you like to see other varieties of the same type. So yeah, this is this is what we've actually done to handle the sparsity problem and recommendations. So we are doing a lot of other cool things, but yeah, that's about it. Thank you.
Thank you, Srikar.